So I've put up this example that we did earlier, having to do with a folium. Recall this was the equation r equals sine 3 theta. We saw that this is this kind of three-petaled flower, and we'd gone through the logic as to why that is. So the question, which I've now put up here, uh, in this cloud is find the area of the blue petal. In other words, let's find the area of one petal of the folium. And even though I haven't drawn it that way, all three of the petals actually have the same area. So if we found the area of one, we would find the area of the others also. We just want to find the area of one petal. So the key here is to understand how we interpret some of the earlier results. I had gone painstakingly through the argument about why it is that that the uh, that the first petal is made by starting with an angle of theta equals 0 and then going around to an angle of theta, going up to an angle of theta equals 3. You can sort of see it certainly makes sense to say that this petal actually exists between those two angles because you can kind of see that it's bounded between this line here and this line here. And the reason that we say that that's what makes the petal is we know that we're starting out at the center where the radius is 0. That's this line here. And then I should point out here, the radius is 0, and then it's at pi over 3 that we come back to a radius of 0. So if we're imagining ourselves kind of tracing this line around, we start at theta equals 0, we keep going up and up and up, and then by the time we get to theta equals pi over 3, we're back to a radius of 0. We've made one loop or one petal. So to find the area of one petal, we're going to integrate the radial function r equals f of theta. We're going to integrate 1/2 of f of theta squared on the interval 0 to pi over 3. So the area, and by the way, if you want a full discussion of the geometry of this figure, you'll have to go back to the earlier discussion of this shape. The area is going to be 1/2 integral from 0 to pi over 3 of sine of 3 theta squared d theta. Okay, so let's recall how we integrate this. This is going to be 1/2 integral from 0 to pi over 3 of, let me write it the way that we usually do, sine squared theta d theta of 3 theta d theta. Recall that when we have a sine squared function, this hopefully goes back a little bit to chapter 8, what we want to do is we're going to use the formula that sine squared u is equal to 1 minus cosine of 2u over 2. So just considering that u in this case is 3 theta, that means that I can rewrite this expression as, I can write it as 1 minus cosine of 2 times 3 theta, which is 6 theta, over 2. Or sorry, I haven't done an antiderivative yet. I'm just converting this. So this is going to be the integral from 0 to pi over 3 of that expression like that. So this now becomes, let's see, 1/4 integral from 0 to pi over 3 of 1 minus cosine 6 theta d theta. That equals 1/4. Now we're ready to integrate. That's going to be theta, and then minus 1/6 sine of 6 theta, and that goes from 0 to pi over 3. So this is going to be 1/4 pi over 3 minus 1/6 of sine 6 theta. So let's see, sine 6 theta, if theta is pi over 3, that's going to give 6 pi over 3, or 2 pi. So that's going to be 1/6 sine of 2 pi, and then minus, let me actually put the 1/4 outside like that. So then we're going to do minus, we're going to plug in 0, we're going to get 0 minus 1/6 of sine 0. We can easily see that this whole thing is just equal to 0. So the answer is going to be 1/4 pi over 3, and sine of 2 pi is 0, so that's going to be minus 0, and what we have is pi over 12. So that's the area of one petal. What is the key takeaway here? All we really did is plug in this formula, is plug in this r equals sine 3 theta into the formula for area between curves. The key to understanding this problem is to understand why it is that we are integrating from 0 to pi over 3 to find one petal. That's the thing that if you want to review this problem, you need to focus on very carefully. So I encourage you, if you don't understand that, to go back to the earlier example where we discussed the geometry of this shape and be clear on why it is that one petal is made by letting theta go from 0 to pi over 3, and then it should be clear why those are the limits of integration.